Assalamu alaikum. Welcome to lecture number 16 of the course on statistics and probability. Students, today is the 16th lecture and the beginning of the second part of this course. As I mentioned in the very first lecture, the first 15 or so lectures were concerned with descriptive statistics. The next 15 are going to be concerned with probability theory, and the last 15 will pertain to inferential statistics. So, पहले 15 लेक्चरों के दौरान आपने मुख्तलिफ टेक्निक्स सीखी of summarizing and describing data that you collect on sample basis. हमारी ज़्यादातर डिस्कशन यूनिवेरिएट सिचुएशन के हवाले से थी, जिसमें हम एक ही सिंगल वेरिएबल को डिस्क्राइब कर रहे थे इन डिफरेंट वेज. And in case of a quantitative variable, we discussed at length the frequency distribution of the variable and its shape, its spread, and its measure of central tendency. Also, in the last lecture, I discussed with you a very important concept, and that was regression and correlation, when we tried to relate two variables with each other. I hope that you enjoyed learning the various concepts that were discussed in the first part of the course, and I hope that you will enjoy probability theory as much, if not more. आप कहेंगे कि ये मुमकिन है कि probability जैसे मुश्किल कॉन्सेप्ट को हम enjoy कर सकें? उससे ज़्यादा तो मुश्किल कोई कॉन्सेप्ट ही नहीं है. Actually, students, this is not the case. This is an impression that is all around, that it is supposed to be the most difficult topic. The only thing is that you need to have a methodological approach. अगर आप उसको एक systematic तरीके से approach करेंगे, तो आप देखेंगे कि it is not really that difficult, and in fact, it is quite enjoyable. In this part of the course, we will begin with the basic concepts of probability, and we will go on to discuss discrete and continuous probability distributions. In particular, we will be discussing the binomial distribution, the hypergeometric and the Poisson distributions, and also the most important distribution in statistical theory, the normal distribution. So let us begin with the very basics. सबसे पहले probability की definition थोड़ी सी discuss कर लेते हैं. What do you understand by the word probability? I'm sure that you will reply that when we are talking about chance, that's what we mean by probability. कि हम किसी चीज़ का कितना चांस है, किसी चीज़ का कितना इम्कान है, इसकी बात कर रहे हैं. जी, बिल्कुल ऐसा ही है. लेकिन in the next few lectures, you will see that there are various ways in which you can define probability. We have the classical definition, we have the relative frequency definition, and then we also have the subjective or the personalistic definition of probability. ये सब definitions हम एक के बाद एक discuss करेंगे, and you will realize that the most important one from the statistical point of view is not the subjective, not even the classical, but the relative frequency definition of probability. Because this is the definition that pertains to real life phenomena, and also a definition which enables you to quantify probability. यानी आप number form में express कर सकते हैं कि for example एक particular event की probability 75% है, एक और event की probability 55% है. इन चीज़ों को हम in detail इन 15 लेक्चरों के दौरान डिस्कस करेंगे. But today we have to start from the very basics. And students, the first thing that we will discuss in this regard is set theory. It will simply be a review of what you have already studied, and the reason why we are going to discuss it is that, as you will see later, there are a number of concepts of probability theory which are facilitated by the use of set theory. यानी set theory के जरिए हम कई concepts को बड़ी आसानी के साथ explain कर सकते हैं. Let us start from the definition of a set. As you all know, a set is a well-defined collection or list of distinct objects. For example, a group of students, the books in a library, the integers between 1 and 100, all human beings on earth, etc., etc. इस definition में I use two words, well-defined collection of objects and distinct objects. इन दोनों से क्या मुराद है? Well-defined से मतलब है that I should be absolutely clear as to whether a particular object belongs to or not belongs to a particular set. और distinct से यही मुराद है कि any particular element or object should appear in that set once and only once. Students, the set itself is denoted by a capital letter, usually, such as capital A, capital B, capital C, and the elements in the set are denoted by small letters. As you see in the examples on the screen, the set A could be consisting of small a, small b, small c, and small d, and the set capital B may consist of the numbers 1, 2, 3, and 7. The number of elements in a set A, this is denoted by NA, and it is called the number of the set A. As you see on the screen, if a set consists of 4 elements, then we will say that the number of this set is 4, and we will write NA is equal to 4. If X is an element of a set A, we write X belongs to A, and if X does not belong to A, then we write it with the same notation but crossing on the notation to denote that X does not belong to A. As you can appreciate, a set can have any number of elements, and if a set does not have even one single element, it is called an empty set or a null set, and it is denoted by the Greek letter phi. But students, please note that the set consisting of the element 0 is not a null set because it contains one element, and that is 0. In fact, if a set contains only one element, we say that it is a unit set or a singleton set. But students, यहाँ ये भी नोट करें कि अगर एक एलिमेंट x की बात कर रहे हैं तो उसके गिर्द हम parenthesis या bracket नहीं डालेंगे. But if we are talking about a set containing one element x, then we will be putting the parenthesis around the letter x, as you now see on the screen. A set may be specified in two ways. The first is called the roster method, and in this method, we give a list of all the elements of a set. For example, if we throw a die, our set of all possible outcomes consists of 1, 2, 3, 4, 5, and 6. And if we toss a coin, our set consists of head and tail. The other method is called the set builder method or the rule method, and in this method we state a rule that enables us to determine whether or not a given object is a member of our set. For example, if we write that A is the set of all x values such that x is an odd number and x is less than 12, this means that we are talking about the set 1, 3, 5, 7, 9, and 11. Speaking of sets, it should be kept in mind that the repetition of an element or the change of order of the elements in a set does not alter the set. Meaning that if I write 1, 3, 5, that is the same set as 5, 3, 1 or 5, 1, 3. The size of a set is given by the number of elements present in it. The number NA, in other words, denotes the size of a set. This number may be finite or infinite. A set is finite when it contains a finite number of elements. Otherwise, it is called an infinite set. The empty set is regarded as a finite set. Examples of finite sets would be the set A consisting of all the positive integers from 1 to 100, the set B consisting of x values where x represents a month of the year, C representing those x values which represent printing mistakes in a book, and D representing those x values which represent living citizens of Pakistan. इन तमाम examples में आप agree करेंगे कि we are talking about finite sets because number of living citizens of Pakistan is not an infinite number. Number of mistakes in a book cannot be an infinite number, and so on. On the other hand, examples of infinite sets are the set of even integers, or the set of all real numbers between 0 and 1, including 0 and 1, or the set of points on a line, or the set of the sentences in the English language. Of course, it can be argued that the number of sentences in the English language is not an infinite number, but the point to understand is that sometimes if the set or if a population is very, very large, so large that for practical purposes we can regard it as infinite, then we do adopt this strategy. On the other hand, in the first three examples, it is obvious that they are really infinite sets because the total number of even integers or the number of real numbers, all the real numbers between 0 and 1, or the number of points on a line, they cannot be regarded as finite entities. ये चार एग्जाम्पल जो मैंने अभी आपको दिए, आप इसमें ये नोट करेंगे कि जो पहले तीन एग्जाम्पल्स थे, the set of all points on a line, or the set of even integers, or the set of all numbers between 0 and 1 inclusive, ये तो वाकई infinite हैं because you can simply not count them as finite entities. लेकिन जो last example था, the set of all sentences of the English language, उसमें तो argue किया जा सकता है कि it cannot be an infinite number, truly speaking. तो इस हवाले से मैं ये कहना चाहती हूँ कि sometimes when sets or samples or populations, if they are so large that for all practical purposes they can be regarded as infinite, then we do adopt this concept. A set that consists of some elements of another set is called a subset of that set. If B is a subset of A, then every member of set B is also a member of set A. For example, if set A consists of the elements 1, 2, 3, 4, 5 and 10 and B consists of 1, 3 and 5, then B is a subset of A. In other words, B is contained in A. Speaking of subsets, it should be noted that every set is regarded as a subset of itself, and the null set phi is regarded as a subset of every set. Two sets A and B are equal or identical if and only if they contain exactly the same elements. In other words, set A is equal to set B if and only if A is a subset of B and B is a subset of A. Speaking of subsets, we also need to differentiate between the proper subset and the improper subset. As you see on the screen, if a set B contains some but not all of the elements of another set A, while A contains each element of B, in other words, if B is contained in A and B is unequal to A, then the set B is defined to be a proper subset of A. A very important concept is that of the universal set. That set of which all other sets are subsets is called the universal set. As you now see on the screen, it is the set which contains all possible elements under consideration. It is also called the space, and it is denoted by either by capital S or by capital omega. An interesting question is, how many subsets can a set have? As you see on the screen, a set S containing n elements will produce a totality of 2 raised to n subsets, including the set S and the null set phi. For example, if we consider the set A consisting of the numbers 1, 2 and 3, this set will contain, it will generate 2 raised to 3, that is 8 subsets, and these subsets are phi, 1, 2, 3, 1, 2, 1, 3, 2, 3 and 1, 2, 3. In the context of set theory, a very important and useful concept is that of the Venn diagram. A diagram that represents sets by circular regions, parts of circular regions, or their complements with respect to a rectangle representing the space S is called a Venn diagram. The Venn diagrams are used to represent sets and subsets in a pictorial way and to verify the relationship among the sets and the subsets. A simple Venn diagram is of the form that you now see on the screen, and the one that you see at this time pertains to disjoint sets, those two which do not have any element in common. On the contrary, if there are two sets A and B such that they have a few elements in common, then the Venn diagram is of the form that you now see on the screen. The next concept that we must concentrate on is the concept of operations that can be performed on sets. Sets can be combined in order to form new sets, and the 4 main operations that we should consider are union, intersection, complementation, and set difference. The union or sum of two sets A and B means the set of all elements that belong to at least one of the sets A and B. That is, A union B is the set of all those X values which belong either to A or to B. For example, if set A consists of the numbers 1, 2, 3, 4, while set B consists of 3, 4, 5, 6, then A union B consists of the numbers 1, 2, 3, 4, 5 and 6. और ये जो नया सेट बना 1, 2, 3, 4, 5 and 6, students, आप नोट करेंगे कि it is fulfilling the basic property that I just mentioned in terms of union. क्योंकि अगर आप इस सेट के एलिमेंट्स को देखें तो some of them belong to A but not to B, some of them belong to B but not to A, and 2 of them belong to both A and B. So we can say that the elements of this set belong to at least one of the 2 basic sets A and B. The intersection of 2 sets A and B means that set in which the elements belong to both A and B. For example, if set A consists of 1, 2, 3, 4 and set B consists of 3, 4, 5 and 6, then A intersection B is the set of the elements 3 and 4, as these are the 2 elements which belong to both A and B. 2 sets A and B are defined to be disjoint or mutually exclusive or non-overlapping when they have no elements in common. That is, the intersection of the 2 sets is the null set phi. For example, if set A consists of all possible outcomes of a die, that is 1, 2, 3, 4, 5 and 6, and set B consists of all possible outcomes when we throw a coin, that is head and tail, then students, it is obvious that these are disjoint sets in the sense that they have no element in common. The difference of 2 sets A and B, denoted by A minus B, is the set of all elements of A which do not belong to B. Representing this point by the Venn diagram that you now see on the screen, the shaded area of the set A represents the set A minus B, because it is all those elements of A which do not belong to B. And the last concept in this regard is that of complementation. The particular difference S minus A, that is, the set of all those elements of S which do not belong to A, is called the complement of A, and it is denoted either by A bar or by AC. Symbolically, A bar is the set of all those X values which belong to S but which do not belong to A. In the Venn diagram that you now see, the shaded portion of the universal set S represents the complement of A, because it contains all those elements which are not contained in A. The next important point to be considered is the algebra of sets, and this is that part of set theory which provides us with a number of laws that enable us to solve a number of problems. The first law is the commutative law, and as you now see on the screen, it is given by A union B is equal to B union A, and A intersection B is equal to B intersection A. I think that you will agree that this law is quite self-evident. जाहिर है कि आपने A और B का अगर यूनियन लेना है तो आपने उनको इकट्ठा करना है. तो अगर आप A यूनियन B कहें या B union A कहें, it is one and the same thing. And the same holds for intersection. The next law is the associative law, and it states that A union B union C is the same thing as A union B union C. And similarly for intersection. The distributive law is given by A intersection B union C is equal to A intersection B union A intersection C. Also, A union B intersection C is equal to A union B intersection A union C. Students, इस लॉ को याद रखने का आसान तरीका ये है कि आप ऑर्डिनरी मल्टीप्लिकेशन और एडिशन का एग्जाम्पल अपने जहन में रखें. When we write A into B plus C, we know that it is equal to A into B plus A into C. इसी तरह से अगर आप इसको देखेंगे तो you will see that it is exactly the same pattern. The idempotent law is extremely obvious. A union A is equal to A, and A intersection A is also equal to A. The identity laws are A union S is equal to S, A intersection S is equal to A union phi is A, and A intersection phi is equal to phi. ये जो आइडेंटिटी लॉज मैंने अभी आपके सामने रखी, अगर आपको इसमें किसी किस्म का भी डाउट हो तो आई वुड लाइक टू encourage you to draw the Venn diagram and to work with it yourself and to decide for yourself whether or not these are correct. Similarly, we have some other laws as you now see on the screen. The complementation laws are given by A union A bar is equal to S, A intersection A bar is equal to phi. A double bar is equal to A, S bar is equal to phi, and phi bar is equal to S. Also, we have the De Morgan's laws, and these are given by A union B whole bar is equal to A bar intersection B bar, and A intersection B whole bar is equal to A bar union B bar. Once again, it is very simple to verify all these laws. आप कुछ numerical examples ले लीजिए. Take examples of sets which contain various numbers and then verify each and every one of these laws. The next concept is that of the partition of a set. And as you now see on the screen, a partition of a set S is a subdivision of the set into non-empty subsets that are disjoint and exhaustive. That is, their union is the set S itself. This implies that AI intersection AJ is equal to phi, where I is unequal to j, and A1 union A2 union A3 so on up to AN is equal to S. Let me explain this to you with the help of an example. Consider the set of all possible outcomes when we throw a die, and that is 1, 2, 3, 4, 5, and 6. Now, if I partition this set into 3 parts in such a way that the first part consists of the elements 1, 2, the second part consists of 3, 4, and the last part consists of 5, 6. Students, this is a partition of the set S into 3 parts, and it fulfills the formal definition that I just presented to you. The union of the 3 sets 1, 2, 3, 4, and 5, 6 is equal to the big set 1, 2, 3, 4, 5, 6, and every one of these three sets is mutually exclusive. 1, 2 is different from 3, 4, and 3, 4 is different from 5, 6. And there is no part of any of these three sets which is overlapping with any other set. The next concept is that of the class of sets. By a class of sets, I mean a set of sets. For example, if you consider the set of lines, this is a class of sets because each line itself is a set of points. The class of all subsets of a set A is called the power set of A, and it is denoted by P of A. For example, if A is the set head and tail, then the power set is given by the null set phi, the set H, the set T, and the set HT. आपको याद होगा कि अब से कुछ देर पहले मैंने आपसे कहा था कि if a set consists of n elements, then the total number of subsets that it can produce is 2 raised to n. और वहाँ पे भी हमने एक एग्जाम्पल कंसिडर की थी. तो अभी जो डेफिनेशन दी उसके तहत उस एग्जाम्पल में जो सेट कंसिडर किया था of the 2 raised to n subsets of the set, that set was also a power set. Another very important and interesting concept is that of the Cartesian product of sets. As you now see on the screen, the Cartesian product of sets A and B, denoted by A cross B, is a set that contains all ordered pairs x, y, where x belongs to A and y belongs to B. For example, if the set A consists of HT and the set B consists of 1, 2, 3, 4, 5, and 6, then the Cartesian product A cross B is the set of the ordered pairs H1, H2, H3, H4, H5, H6, T1, T2, T3, T4, T5 and T6. इस सिलसिले में important point ये है कि in general A cross B is not the same thing as B cross A, because if you consider the graph in which x is on the x-axis and y is on the y-axis, you will readily agree that 1, 2 is not the same point as 2, 1. Students, I have discussed with you the basic concepts of set theory, which I am sure that many of you are already familiar with. But it is good to revise and to refresh them in your mind, because as you will see in the forthcoming lectures, this theory will be very, very useful for us when we talk about probability and a number of probabilistic problems. Another important mathematical theory which we will be using in solving probabilistic problems is the theory of counting rules. There are 3 rules that enable us to solve a number of problems in a convenient manner, and these are the rule of multiplication, the rule of permutations, and the rule of combinations. And I will pick them up one by one. As you now see on the screen, the rule of multiplication is stated as follows. If a compound experiment consists of 2 experiments such that the first experiment has exactly m distinct outcomes, and corresponding to each outcome of the first experiment, there can be n distinct outcomes of the second one, then the compound experiment has exactly mn outcomes. स्टूडेंट्स, ये रूल इतना मुश्किल नहीं है जितना कि आपको महसूस हुआ. In fact, it is extremely simple. Let me explain it to you with the help of an example. Let's go back to exactly the same one that we discussed a short while ago. One set consisting of HT and the other one consisting of 1, 2, 3, 4, 5 and 6. I'm sure कि आपने उस वक्त भी realize कर लिया होगा कि this is the case of tossing a coin as well as tossing a die. The coin can result in 2 possible outcomes, head and tail, and so M is equal to 2, and the die can result in 6 possible outcomes, and so N is equal to 6. Now, according to the multiplication rule, the total number of ways in which this compound experiment can be performed is M into N. So, in this case, it is 2 into 6, and that is 12. And students, as you will remember, 12 is exactly the number of ordered pairs that we had when we considered this example earlier. As you now see on the screen, the 12 ordered pairs are H1, H2, H3, H4, H5, H6, T1, T2, T3, T4, T5 and T6. ये जो example हमने अभी discuss किया, इसमें we considered 2 simple experiments being performed together to give us the compound experiment. But students, this can be extended to any number of simple experiments which are being conducted together to give us the compound experiment. And the other point is that this rule of multiplication या multiplication theorem ये जो है, this is also called the rule of multiple choice. And the example that I will now consider and discuss with you will portray this point clearly. As you now see on the screen, suppose that a restaurant offers 3 types of soups, 4 types of sandwiches and 2 types of desserts. Then a customer can order any one out of 3 into 4 into 2, that is 24 different meals. ये तो बहुत ही ज़्यादा delicious example था और मेरी तरह आपके मुंह में भी पानी भर आया होगा, लेकिन रेस्टोरेंट तो हम बाद में जाएंगे. Let us consider the points that I just conveyed to you. देखिए, इसमें 3 simple experiment हैं. The choosing of one soup out of the 3 possible choices, the choosing of one sandwich out of the 4 possible sandwiches, and the choosing of one dessert out of 2. इससे आपको convey हो गया होगा why this rule is also called the rule of multiple choice. दूसरी बात कि जैसा मैंने कहा कि इसमें 3 simple experiments हैं, the choosing of the soup, the choosing of the sandwich and the choosing of the dessert. So, we are extending the initial rule Mn to the case of 3 experiments, and we are now applying the rule M into N into P, where M is the number of ways of choosing a soup, N is the number of ways of choosing a sandwich, and P is the number of ways of choosing a dessert. Let us consider another very interesting example. Suppose that we have a combination lock on which there are 8 rings. In how many ways can the lock be adjusted? यानी एक combination lock की बात हो रही है, जिस तरह के आजकल suitcases पर भी अक्सर होते हैं. And this lock has 8 positions, and we are trying to determine how many different ways in which we can adjust or set this lock in order to lock the suitcase. अब students, इस problem को हम किस तरह से approach करेंगे? देखिए, the logical way to go about it is to think of the 8 positions and to realize that for any one of those 8 positions, it can be filled in 10 different ways. इसलिए कि there are 10 digits from 0 to 9 और जो पहली पोजीशन है उस पे भी 0 to 9 कोई भी डिजिट हम रख सकते हैं. Same for the second position, same for the third, and same for the 8th. So, if we apply the rule of multiplication, we find, as you now see on the screen, that the total number of ways of doing this is 10 into 10 into 10 and so on, so that the answer is 100 million. Can you imagine 100 million ways of adjusting that lock on your suitcase? 100 million yani 10 crore. And the formula in this case, when all 8 positions have the same number of possible ways of being set, the formula can be simply stated as 10 raised to 8. 10 into 10 into 10, 8 times. Lekin fundamentally, it is the same rule that I have been discussing for the past few minutes, the rule of multiplication. Students, this brings us to the end of today's lecture, and in the next lecture, I will discuss with you the other 2 very important rules which enable us to solve a number of problems in probability theory, the rule of permutation and the rule of combination. After that, we will proceed to the real thing itself, and that is probability. Until next time, my best wishes to you, and Allah Hafiz.